Hello everyone, today we are going to speak about bitwise operators in Java with example and explanation. What are bitwise operators? Bitwise operators in Java are used to perform operations on the binary bits of integer and long data types. They work faster than arithmetic operators because they work at bit level. Because our computer can understand the zeros and one. That's why bitwise operators are faster than the arithmetic operators. Types of bitwise operators. First we have learn AND operators. Bitwise AND return 1 if both bits are 1. Our 12 is written in binary as 1100. But we can represent it in 8 bits, and our 7 is represented as 0111, and in 8 bits it is shown on the figure. If we 01, answer is 0 because our condition is if both inputs are 1 then only output is 1. 111, 100. Bitwise OR returns 1 if any bit is 1. It's our 12 and it's our 7, 0, 1, 1 because if any either bit is 1, our output will be 1. Next is our bitwise XOR. Returns 1 if bits are different. If our inputs are different, one is 1 and another is 0, then our output will be 1. Our 12 is here, it is our 12 and it's our 7. It returns 1 when it is both inputs are different. It returns 0 because both inputs are same. It returns 0. If both inputs are same, then it returns 0. Either it's 0 or 1. Bitwise complement. It flips the bit. If it is 1, it flips to 0. If it is 0, it flips to 1. Our 12. 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1. It's minus 13. To know how it is minus 13, first we consider the 13. To convert 13's binary to minus 13 binary, we have to find 2's complement of 13. To find negative of 13 in binary, it's our 13. First we have to convert its 1 complement. 1 complement is bits. It just flips the bits. If it is 0, it converts to 1. If it's 1, it converts to 0. To find 2's complement, we have to add 1 for it. If you add, this is our output, which is equal to our 12's complement. So that's why our answer is minus 13. Left shift operators move bits to left. Example 12 left shift 2 means we have to shift 2 bits to left. It's our 12. First we shift the 1 bit. Simultaneously we shift the 2 bits because it mentioned that we have to shift 2 bits. If you want, you can shift 1 and after that you can shift 1 bit. It's also okay. Our 0 comes here, 0 comes here, and our 1 comes here, and our 1 comes here. After that, remaining 2 bits are appended with zeros. In left shift we append the number of bits, how many bits we have shifted, that many zeros to the right side. Now in our decimal this is answer is 48. Right shift and unsigned right shift. Move bits to right. Unsigned right shift also is same, but if it's negative number it will give the positive answer only. It will append zeros to right side. Example 12, right shift 2. We have to shift 2 bits to right. Zero comes here and we have to append 2 zeros at left side. In our decimal answer is 3. It's our Java code and the output of that code is here. You can check, or you can first calculate and then check the output. Thank you.